Hey robot fans, welcome back to the build. Last time we got Chopper's feet motorized and driving around. Today we're going to see if we can get those feet attached to the body and have the whole droid drive around. Right off the bat, I've updated the foot from the last video. I got some feedback from the Facebook Chopper Builders group that I might run into some clearance issues with the bottom of the foot. I decided to drop those wheels down a little bit to give me a full 1.5 inches of clearance. I also reduced a lot of the bulk of the frame to make it a little bit easier to print. The mechanical guts of the foot are still identical, just the frame has been shifted and reduced. A lot of builders tend to name their foot drive, so I decided to name mine the Bluth Stair Car. If we take a look back at the functionality we discussed in episode 1, I want Chopper to be able to switch from 2-leg mode to 3-leg mode. At first this decision was strictly for the cool factor and a little bit of builder cred, but as I was developing the head arms and trying to animate them and working in the head nod animation, I realized that those functions will work a lot better on a fully upright droid. Also, they'll look a lot better on a fully upright droid, so I'll do all of my driving in 3-leg mode and then stand him up straight for all the extras. Keeping this function in mind is really important while we build the leg. This axle here will be fully free spinning, so we need to be able to lock it into place to keep Chopper from toppling over. We also need to be able to keep the foot parallel to the ground as the droid transitions from each leg mode. If we take a look at the stair car, I have a second axle in place. I'm going to connect this to a rigid axle running through the body using a piece of M8 studding. We can worry about all the hardware parts later, but for now we just have to keep this channel in mind while we build the rest of the parts of the leg. The length of the leg is going to be under a lot of stress, and since I can't print it all in one piece, I want something solid running through the leg so there isn't as much force being applied to the joints. Back in episode 4, I bought some linear slides that I ended up not using for the head arms. I'm going to repurpose those rods as studding running through the length of the leg to keep everything as sturdy as possible. All the printed pieces will slide onto these rods with the ankle and the shoulder acting as a cap on each end. The channel for the standing rod will run up through the middle, and another channel will run from the tip of the ankle all the way up through the side to route the wires. I purchased some hollow stainless tubing to use for these little hydraulic rod things on Chopper's legs, so that'll be perfect for housing all the wires. While all this is printing, we can start tackling the shoulder side of things. Continuing right along with the theme of getting it right the second time, I'm going to have to enlarge the current shoulder cavity from here to here, so all of these crossbars are going to have to go. I'm going to take this time to address the number one frequently asked question I receive: when are you going to release the print files for Chopper? To which I always reply, when I know everything works for sure. I hope this little video of me hacking into my droid supports my case a bit for holding off on releasing the files. After cutting the bulk of the shoulders off, I dremelled everything nice and flush so I can install our new shoulder. This shoulder gives a little space for a main axle as well as the rigid axle to attach to the foot and recesses for our rotating connections to the leg. The heavy lifting of the 232 leg transition is going to be done by these two linear actuators. I got them off eBay. They are 24 volt actuators with a 3-inch stroke. They can lift 330 pounds at 10 millimeters per second. These will be positioned inside the body just behind the shoulder and push and pull an arm, which will give us the rotation around that axle. This interior arm will attach to the shoulder using 4 M12 bolts, which will rotate freely through the holes in the shoulder. To print this interior arm, I got to employ one of my favorite printing techniques, which is to pause the print at the correct layer, insert the hardware, and print over top to capture that hardware, in this case 4 M12 nuts, into the final printed piece. Since the end of the arm will be tracking the circumference of the circle, I had to build a piston-type mechanism to allow the linear actuator to push this area as it moves in and out of the actuator's line of travel. To add some control to this mechanism, I've installed 2 end stops on each shoulder. These will be triggered by a little dangly ball attached to the bottom of the arm. I can't help but think of Butters in the Freak Strike episode every time I look at this, but having this little chin ball here allows me to reprint it as needed to really dial in the angle of the rotation. I've built my latest and greatest of temporary control boards. This will be the last temporary one I have to build, I hope. It's pretty simple. It's just an Arduino controlling 2 BTS7960 motor controllers and receiving feedback from those 4 end stops. I also set up a little temporary button to trigger the leg transition. I'm going to do a couple quick tests of the end stop code as the legs are getting done on the printer. The code is pretty simple. When I push the button, it drives the motor until it hits an end stop. That end stop cuts the motor and changes a variable value from true to false. That value determines the direction of the motor on the next button push. Now that the legs are done printing, I can assemble them while routing the wire and the 8mm standing rod. The wire will have a detach point here at the foot, but that's going to be a little bit tricky to get to once the foot shell is on, so the main detach point will be inside of the shoulder bell. This connection will allow me to take the legs off as needed for both maintenance or if I have to take them off to travel somewhere. This connection will eventually be bullet connectors like in the foot, but I can't do that until after my final post-paint assembly, so for now I'm going to use these Wago nuts. From there, the wires get routed through the axle and into the main cavity via some holes I drilled with my new super badass Teenage Mutant Ninja Turtle looking drill bits. This is the final hardware configuration for the standing bolt. It's a piece of M8 studding attached to two different types of loops at each end using some coupler nuts. One is an M6 eye loop with an M8 shaft coming out, and the other is custom printed. I cut all this down to size and left a little room in my couplers for tightening later on. The leg has a large bearing in the back similar to the one in the shoulder, and this will press up against a bushing to keep it properly spaced against the body. An M12 stud will be placed through the length of the body, which will act as our standing bolt anchor as well as be an anchor for the top of the third leg assembly when we get there. With all that installed, we could do our first transition from 2 legs to 3 legs. Obviously, we don't have a third leg yet, so I'm just going to have to hold the droid up, but we'll be able to see the legs move into their proper angles. Okay, here we are, 3-leg position. Not sure quite what the angle will be with that foot down, but probably somewhere in here. Then when we push the button again, it returns to 2-leg position, which is great. We can also take Chopper for his first 2-legged spin. He's still running smoothly on some very conservative 12-volt throttle. I'm very confident that this droid will run as fast as I wanted to with all the additional weight that's going to be added. I think that is going to do it for this video. The next big step to take here is going to be adding in that third leg, but I think before I do that, I may do a quick video on the front utility arm. I want to block out that space before I start designing the third leg, so stay tuned for that. If you like these videos, please consider subscribing. We have to keep the YouTube algorithms on our side, and every subscription, like, and comment really helps these videos get seen by more people. So click this button to subscribe to my channel, or if you're not yet convinced, click this button to watch a video from my clone build series. Alright, I'll see you next time.